Hello students, welcome back to my channel. So we are learning the chapter 13, that is database concepts. In the previous session we had learned about the different data types of DBMS, as well as we had seen an important topic, that is the feature of database management system. So in today's session we will be learning one more important topic, that is about data abstraction, with which along with that we are going to be learning a three schema architecture, wherein which we will see the different types of data independence, that is your logical data independence as well as physical data independence, and what is the meaning of that, right? So let us start with data abstraction. So what is a database abstraction? The database users are provided with an abstract view of the data by hiding the certain details of how data is physically stored. Now, when I say this, what I meant is, um, just an example, if you're seeing, you are going to Google Chrome and you are typing something, saying, for example, DBMS, isn't it? So when you click, there will be a list of websites which will come, and when you click them again, you will be directed to that particular web page. Now there what is happening is you're accessing the content from that particular website database, isn't it? But you are not aware that how the data is stored in their database, which location it is stored, or from where it is coming into your system. You're sitting at home and accessing their database. So that is what here when I say data abstraction, it is nothing but hiding the details of the how the data is physically stored from the user, right? So data abstraction is a process of hiding unwanted or irrelevant details from the end user. So what you are bothered about is only the content. You are not interested in how they are storing the data, where they are storing the data, what is the structure they are using, what is the data kind of a security they are using. You're not bothered about that. You are only bothered about the contents what they are providing, isn't it? So that is where our data abstraction comes in picture. So it provides a different view and helps in achieving a data independence, which is used to enhance the security of data. So this is very important, data independence. We are going to see it now, that how it is achieved. Okay, so this is the one which provides us security of data. So this is about data abstraction, definition and an introduction. Okay, now let us see what is a three schema architecture of a databases and how it enables us with the data independence, right? Okay, now what you see here is a three schema architecture of a database. So I have your end users. Okay, this is where usually we will be sitting. Okay, then I have something called as an external view, then I have conceptual level, then I have internal level. So these are the different levels. So then I have external view, then I have conceptual schema, then I have internal schema, and if you see, my actual data or the database is here, that is stored database. This is where my actual data is lying. So what is this different levels? Okay, so in this architecture, the overall database description can be defined at three levels, namely internal, okay, internal, conceptual and external levels, and thus named three level RDBMS architecture. That is the reason we are calling it three schema architecture, or sometimes we will also call it as three level RDBMS architecture. So this architecture is proposed by ANSI SPARS, that is your American National Standards Institution, okay, or Standards Planning and Requirements Committee. So they are the one who proposed this. So ANSI SPARS. So let us see them one by one. Let us start with the internal level. What is the meaning of this? So internal level is the lowest level of the data abstraction that deals with the physical representation of the database on the computer. Hence, it is also known as physical level. So sometimes apart from internal, it is also called as physical level. Okay. So what does it do? It describes how the data is physically stored and organized on the storage medium. So this is nothing but my storage medium. Here in the physical level, I'm going to explain all the details about how my data is stored in the storage devices. Okay. Also at this level, various aspects are considered to achieve optimal runtime performance and storage space utilization. Okay, so these aspects include storage space allocation, techniques for data and indexes, access paths such as indexes, data compression and encryption techniques, and record placement. So all this, everything related to storing a data happens at the internal schema or the physical level. Next comes our conceptual schema. So what is happening here? This level of abstraction deals with logical structure of the entire database. So here we are only going to see the logical structure of the database. That is why it is also sometimes called as logical level. So we have two names here: conceptual or logical, physical or internal. Right. Conceptual level describes what data is stored in the database, the relationship among the data, and the complete view of the user requirement without any concern for the physical implementation. So I'm not going to talk about how my data is going to stored here. I'm only bothered about how data. For example, if I have a student, he's studying some course, what are the things I'm going to store here? For example, course number, okay, and his student number, all those things. Here also under the student I'm going to have register number, his name, and how these two, student and course, are related, everything about the data, everything about the content, how they are related. You can also take an example of ER model. We are going to learn them. So ER model, if you know already, that is nothing but entity relationship model. So here we are going to learn about how different entities are there in the database, how they are related to each other. All those conceptual things are formed in the conceptual schema. Here we are not going to discuss anything about how the data I'm going to store in the database. Only the conceptual things I'm going to discuss in my conceptual schema. Right? Next comes my external view. So what has happens in external view? External level is the highest level of abstraction that deals with the user's view of the database, and thus is also known as a view level. So apart from external level, I will also call it as a view level. Okay. In general, most of the users and application programs do not require the entire data stored in the database. The external level describes a part of the database for particular group users. It permits user to access data in a way that is customized according to their needs, right? So if you are looking for a code, source code of that particular web page, then you will be given to the source code, not in all the cases. But you are not looking for the source code if you are looking only for the certain part of the content. Okay, for example, there is a web page which tells everything. It has a ingredients. Okay, for example, it is a cooking web page. It has ingredients, it has steps, it has temperature details, all those. A few may be interested only in the ingredients. Okay, maybe his job is only to buy, go to the shop and buy stuff. Other person is maybe interested in how, what is the exact method. Okay, because maybe he's the one who is cooking. So that is what I mean. So this is just an example. So the database is a huge database. When I say, it will have lot of data, but in the external view, whatever the user is interested, only one part of the data will be given or shown to the user depending on his requirement. Okay, so if he wants only ingredients, I will show him only ingredients. If he is wanting the entire recipe, then I will give him the entire recipe. That is what the external view means. Now this person will not have any idea about the conceptual schema, saying what are the entities, what are the relationship, how they are related, all those things, nor he will have the idea about the how the data is stored. Similarly, person at the conceptual schema, database application developers, they will not have any idea about how the data is stored. Here is where your database administrator will be sitting. He will have the knowledge about everything, right? So this is your three schema architecture. So how it is helping in the data independence? So what is this data independence? Okay, so data independence is an ability of the database to modify a schema definition at one level without affecting the schema definition at the higher level. What is the meaning of that? So I have external schema, then I have conceptual schema, which we have seen already, then I have physical level, isn't it? So now when I say the data independence is an ability of the database to modify a schema definition at one level without affecting the schema definition is the next higher level, which means if I am doing any changes to the physical schema, next higher level, these people should not get to know about it at all. Nothing should change for them. Similarly, if I am doing a changes to the conceptual schema, the external schema, the user should not get to know about it anything. Okay, so that is what data independence, and that is supported by our DBMS concept, that is your three schema architecture. So data independence occurs because when the schema is changed at one level, the schema at the next level remains unchanged. So suddenly if I am storing it in a hard disk all this while, suddenly if I am changing it to CD, still user is accessing the database, he should not find it difficult or different. Okay, so that is what I mean. Here, entity relationship, there is some relationship I'm going to change. I'm going to add a new column. I'm going to add a new row at the conceptual level. Still, the external level user should not get to know. Similarly, when I'm changing the physical structure also, conceptual as well as external, people need not change their interface or the way they are working with the database. So that is what it means. Now there are two types of data independence. One is called as a physical data independence. Other one is called as a logical independence. I think by now you have understood what is the meaning of that. Okay. So see here, under data independence, I have physical data independence and logical data independence. So what is the physical data independence? For example, if you're changing any file organization and data model, okay, and the database architecture. So when you're doing this change, there is no changes or it does not affect your conceptual schema or your external schema. That is called as a physical data independence. Similarly, when I say logical data independence, normalization rules, relational rules, so this normalization again we are going to learn in detail, but entity relation, like I said before, the concept or the structure, the table, whatever you're creating, if you're doing any changes in that, it will not affect the external schema. That is called as a logical data independence. So let us see them in detail. So see here, physical data independence. Physical data independence is defined as the ability to make changes in the structure of the lowest level of the database management system without affecting the higher levels. Okay, hence modification in the physical level should not result in any changes in the logical or your external view. Okay, so see the example is changes in the lowest level are creating a new file. Okay, for example, you have added one more file here, or storing a new files in the system, creating new indexing, you have changed the indexing, or you have added one more hard disk. Okay, adding a file is nothing but you have added one more hard disk. All these changes should not affect the your logical or external level. That is when it is called as a physical data independence. That is why it is an ability to make changes in the structure of the lowest level of the database management system without affecting the higher level schemas, right? Next we have is logical data independence. So what is this logical data independence? Logical data independence is ability to modify the logical schema. You should be able to change this without causing the application program to be rewritten. So application program is nothing but external level. Okay, so when you are changing the logical level, the external level should not have any effect. That is when it will become logical data independence. So modification at the logical level are necessary whenever logical structure of the database is altered. Of course, because when I say database, it is nothing but it represents a real world, isn't it? Maybe your university, I'm creating a database for your university and they have started a new course. At that time, I will have to add one more entity or one more table here. So that time it will change the logical level of your database, but that should not have any effect on the external view of the database. So that is called as logical data independence. Okay, see here, when money market accounts are added to banking system, that is you are adding some new feature into the banking system. Just like I said, you're adding a new course to the university. Okay, you're adding some new feature to your banking account. That time it should not change the external level. That is called as a logical data independence. Okay, so this was an important topic, students. That is your three schema architecture of DBMS as well as data independence, in which logical data independence and physical data independence. I hope you are able to understand it. I've tried to explain it in a simple way, right? So that's all in today's session. Keep learning and thank you for watching.